Hello and welcome to this special AI coffee break. Today's video is a bit different from my usual content. I recently defended my PhD dissertation successfully, and after sharing pictures of this academic milestone, many of you have asked about my PhD journey, the work I did, the challenges I faced. So I thought it would be fun to share my experiences with you in this special video. I'll take you through my entire PhD journey from when I decided to pursue a PhD to the duties I had to fulfill, like teaching. Spoiler alert, there was no unhealthy amount of coffee involved, well, except for Miss Coffee Bean. I'll also show you my PhD hat, I'll give you a brief rundown of the research that went into my thesis, and I'll explain why I decided to start this YouTube channel during my PhD. I hope that by sharing my story, I can provide some insights and inspiration for anyone considering or currently pursuing a PhD. But remember that this is just my experience, it's my data point in a vast universe of PhD adventures out there. So grab a cup of coffee and let's start. First, let me tell you a little bit about why I decided to pursue a PhD and how I started on this journey. My decision to start a PhD hit me while I was wrapping up my master's degree in physics. Funny enough, my master's thesis wasn't your typical physics project. I was actually doing machine learning in image processing, and I found myself utterly fascinated by the possibilities of what machine learning and AI can do. I've always had academic ambitions, so diving deeper into research felt like the natural next step. But I cannot give you a more noble motive in the grand scheme of things because, let's be real, life's big decisions are often a mix of timing, place, and the people who are next to you and inspire you along the way. Now, about my research topic. My interest in image-related AI and machine learning sparked a curiosity to understand more about humans. What exactly makes people snap a photo? And what words do they use to describe those images? Here's where it gets interesting. To truly get to the heart of this, I realized I needed to dive into language. After all, language and vision are intertwined. They both describe our actions and observations of the world. And this was before large language models were all the rage. The next part of the puzzle was to choose the location. My partner had already started a PhD in Heidelberg, so naturally Heidelberg became the only option for me. After some searching, I found a professor in the computational linguistics department who was brave, or perhaps crazy enough, to embark on a research journey with me to combine image and text understanding, which is called multimodal understanding. This professor specialized in natural language processing, while I brought the expertise in image processing to the table. Together, we set out to explore deep learning models that can use both vision and language. It was the perfect blend of our skills and interests, and thus began my PhD adventure. I started my PhD in 2019, and it took me just a bit more than 5 years to complete. Before I could even really start, I had 6 months to prove that I could work in natural language processing, or short NLP. And I was encouraged to take one master's level course to see how it all works there. The reason was that I had studied physics for bachelor's and master's. It was not enough that I had done all my research projects in physics on computational and machine learning topics, and also that I did a computer science bachelor's too while studying physics. The problem was that I had not done any text processing before, just image processing. So I was technically a newcomer to the field and I had to learn NLP. It was quite amusing actually. I ended up explaining the math and neural network bits to the more seasoned NLP students because this was right when the NLP was being revolutionized by transformer neural networks. Before, NLP leaned heavily on linguistics, but now it was all about neural algorithms, which require quite a bit of linear algebra, calculus, and probability theory knowledge, so things I knew from physics. As you can see from the linguistic knowledge that went into ChatGPT, NLP of today requires much less hardcore linguistics than it used to. Then all 5 years were a mix of doing research, teaching my own courses independently, and going to a conference each year after publishing a paper there. My whole PhD, by choice, was quite unstructured in the sense that I needed to write a research proposal, yes, but in the realm of AI and machine learning and everything moves so fast, I knew that from the proposal only the broad interests and research questions will last, because the methods and the data sets will certainly change. And they did change. When I started my PhD, image and language networks were CNNs and LSTMs concatenating their vectors. Then suddenly came transformer encoders, and now transformer decoders are all over the place. Anyway, I did research, writing my own papers, which I knew would be part of my PhD thesis, but also other papers in larger collaborations that helped build up my skills. For starting collaborations, it was important to talk to people at conferences and meet them. It does not help to be shy. Even I know it can be scary at times to approach a person that you know and admire because you read all their papers. But here's the thing, what's the worst that could happen? You might embarrass yourself and they might ignore you. But guess what? They were already ignoring you because they did not know you existed. And the odds that the conversation will turn out all right and they will not end up hating you is quite large. Also, if you do not have the opportunity to meet someone in person, usually cold emailing works pretty well among researchers. Just bear in mind to email them about something they might find interesting. The worst that can happen is you not getting any response. I'll talk about the research in a bit, but first I'll tell you about the side activity that came with my position at the Institute, namely the teaching. I had the freedom, but also the responsibility to choose my own courses and topics that I wanted to teach. So I decided that in each winter term, I would teach a bachelor level, so an undergrad course about taking their first steps and designing their first experiments with simple machine learning methods. Since it was at the undergraduate level, I had to teach this course in German. Then every summer term, I would teach a master's level course about deep learning methods that do not require annotated data, but work unsupervised or with self-supervision. We started with PCA and clustering and got into variational autoencoders, generative adversarial networks, transformers, state space models, diffusion models, and so on. Teaching was a significant time commitment and one of the reasons my PhD took a bit over 5 years. With all the preparations and weekly classes, it could have easily turned into a time sink. But it taught me a crucial lesson that applies to YouTube as well. Striving for perfection is a trap. The time needed to take a lecture or video from 80% to 100% perfect is disproportionately large and often not worth it. What does 100% perfect even mean? I could create a perfect video for you, but is it a perfect video for the person sitting next to you with a different background and different questions? So I learned to let go of some of my perfectionism and actually get stuff done. Now, why did I have to teach? In Germany, at least in STEM, PhD students typically receive a decent salary. Some students get funded by scholarships, which are prestigious but often offer less money and benefits. Other students are paid through their professors' grant money. I was an academic employee of the university, meaning I got a bit more money, but in return I had to teach and perform some administrative duties for the institute. The big perk? Academic freedom to research any topic I wanted, unlike grant-funded students who are often tied to specific research topics. Teaching turned out to be an invaluable experience because it boosted my communication skills and it was actually the primer for me starting my YouTube channel. More about this a bit later in the video. Okay, so after 5 years of paper writing, teaching, and going to conferences from time to time, it was time to bring it to an end, writing the thesis. I managed to write it in 2 months. On the one hand, it felt natural since paper writing and scientific writing is something that I had exercised already with almost 11 papers. But it was stressful too because I decided perhaps a bit too late to do extra experiments for each chapter to make them well-rounded. So it was not only thesis writing that I was doing, but I was also running experiments and compiling them into a new paper and the thesis. All in all, the lesson from this experience: just start writing already. The hardest bit is putting a word on the blank document. Once that is done, the content will come together. Don't forget to first decide on the structure you want to follow, and most importantly, keep writing even when you feel that the sentences and ideas are not perfect. You will improve them later in the next pass, because it is easier to edit content when all is put together than it is to write something perfectly on the first try. Despite the chaos of last-minute experiments, those 2 months of basically non-stop sitting at the computer were both stressful and peaceful. Peaceful because I could tell everyone I was in deadline mode and they left me alone. I was fully in the zone. Plus, about 1.5 months were during the semester break, so no teaching duties. Eventually, I handed in my thesis. A few months, some more teaching and a bit of job interviewing later, it was time for the grand finale. My PhD defense. The defense was a very comfortable discussion event that lasted around 75 minutes. I had to kick things off with a 15-minute presentation summarizing my entire thesis. So the next time you find yourself grumbling about having to give a 10-minute presentation on a project you've worked on for a few weeks, spare a thought for me. I think actually that keeping a presentation concise is a great skill to exercise, so I actually liked how this was organized. My talk was followed by the Q&A part of the exam. It was a lively conversation with the PhD committee that was asking me question after question. I felt confident during the entire conversation. I was feeling like I had the answers. After all, it was about what I have done in the last 5 years of my life. All in all, the defense went incredibly well. My only regret is that the faculty rules meant seating was very limited, so not everyone could attend. Even worse, I wasn't allowed to record or stream this event on YouTube. But 75 minutes later, I emerged from the exam room victorious, and my colleagues were waiting outside to present me with the PhD hat that they had made for me. A PhD hat? Yes, this is common practice in Germany, so let me show you the hat. Here is the hat. It is quite normal in Germany to receive a PhD hat assembled by fellow PhD students in secret before the defense, hoping that the defense goes well. And then when the candidate exits successfully the examination room, they give the candidate such a hat. Creativity is very much asked because this hat should somehow represent the time as a PhD student and also the personality of the PhD student. So yeah, I mean, no wonder that this hat is structured like a YouTube video for me, where Miss Coffee Bean sits in a corner, like she usually does. We have Nutella because I ate a lot of Nutella during my PhD time. I love to sail, so there's a PhD hat sailboat here. Instead of chapters for the video, there's the most important milestones of my PhD, namely my most important papers and their first figure. Here is the time I needed to complete my PhD in terms of hours, minutes, and seconds, like a usual YouTube video shows it. And really, they put these last numbers when I exited the examination room with the last update. Instead of the subscribe button, there's the cite button. Instead of the title of the video, there's the title of my thesis. And here they put as a channel logo a merge sticker for the channel. And yeah, maybe you're wondering what these dangling little PhD hats are on the side, because we can see a complete PhD hat, a tiny version, and deconstructed versions of it, like even no hat. And the reason is that I used a lot of Shapley values during my thesis, and Shapley values are all about deconstructing the inputs in all possible combinations to see how the model reacts, including just no input. So they put this idea onto the hat in a very original and really nice way. So yeah, I just love it. Thank you very much, guys, for doing it. It's really great. I'm so proud of it. Now, I would like to give you a short taste of what my research was about. You might find it a bit over-specialized since a PhD is of course very specialized. But it's okay, I forgive you if you just skip to the next part where I'll talk about the challenges I encountered during my time as a PhD student and about why I decided to start a YouTube channel during my PhD. I'll also give some tips for prospect PhD students. I would like to start by asking, why is it important to have multimodal systems that can process both vision and text? When humans communicate, they naturally ground language in the visual world, thereby exploiting their shared experience, sometimes even keeping visual information implicit. To make machines understand language, it is important to model how language is grounded in the visual world, opening the way for many applications like personal assistants, robots, self-driving cars. Unfortunately, this is a major challenge because images and text, the two modalities of concern in my thesis, are very different. Language is symbolic and abstract, while vision is very detailed, concrete, and often unambiguous. Vision and language models, or short VLMs, at least try to fuse images and text. These models can be either vision and language encoders composed of transformer layers processing the image and the text, trained to increase the image-sentence alignment for fitting images and captions, or trained in a multitask fashion on other objectives such as masked language modeling to predict masked out words or regions. They can be also decoder models that autoregressively produce text from inputs composed of text tokens and image tokens. They're usually initialized with language models and further enhanced and trained to process image tokens as well. But there are clearly problems with both types of models in their ability to understand, use, and fuse images and text. Just to name you an example, it's pretty alarming that models can answer to questions about the image correctly even if we forget to give the model the image's input. For example, this can happen because of plausibility biases. If somebody asks if there is an object in an image, usually it really occurs there. Also, there are other dataset biases where the most common answer to how many questions in the data is anyway 2, so models can pick up on such shortcuts which can allow them to neglect the problem of actually fusing information from both modalities. So, not only do VLMs struggle to understand, fuse, and use the two modalities, also they lack interpretability, so we do not know exactly why they fail when they do. So in this thesis, I analyzed how well the multimodal fusion of vision and language is performed in VL systems by means of model benchmarking, model interpretation, and investigating whether models can reliably self-interpret with self-explanations. Now, we start with the part about benchmarking. In our benchmark called vals, we disentangle model capabilities by a set of linguistic phenomena, namely existence, plurality, counting, relations, actions, and coreference. We frame this in a foiling setup where models are presented images paired with the original caption, and a variant where a grounded phrase is replaced by a so-called foil that is not describing the image anymore. We have a couple of strategies to automatically generate foils. We let language models propose likely foil words. We automatically check the grammaticality of the new sentence with grün. We use natural language inference models to filter out examples where the foil entails the caption, because if so, it's still likely describing the image. And we also use human annotation to validate all automated steps conducted before. We test VLMs in two zero-shot settings, in an easier one called pairwise comparison, where the model chooses whether the caption or the foil describes the image better. And in a harder classification setting, the model predicts whether a caption or a foil describes the image or not. And we find that VLMs understand object-centered phenomena, but they do not understand phenomena involving object relationships. And interestingly, decoder VLMs and LLMs are great at a setting where they can compare captions and foils and then choose what's the best, because that's where they can use their strong linguistic priors. And the weaker performance in the classification setting, which is much harder, shows that even the newest decoder models struggle. So VALS stands the test of time by still being unbeaten for 2 years, which in machine learning is a great deal of time. Also, VALS stands out as one, if not the earliest benchmark to investigate the grounding capabilities of vision and language models through the lens of linguistic phenomena. So now that we have seen the part about benchmarking, let's look at the second point regarding the difficulty of models to effectively use both modalities, because we know that somehow they work even if we delete the image, which actually contains crucial information to answer questions about an image. So we interpreted the model to measure the contributions of individual modality to a model's prediction. Measures aiming at this before were all accuracy-based, basically looking at the model accuracy with and without the modality, but such performance-based metrics imply that when the model delivers an incorrect result, it did not pay attention to a certain modality, only that the model could have had relied on the modality just incorrectly. So we proposed a performance-agnostic measure to this by using Shapley values, a concept from game theory, used to determine a fair payout to all players, accounting their contribution to the outcome of the game. And in machine learning, players are tokens, which get Shapley values representing their contribution towards the probability of the model output, here 100% positive sentiment in a language-only example. And we extend Shapley values to the multimodal domain and use them to define a percentage of how much text tokens versus how much image tokens contributed to a certain prediction. And we can get sample level interpretations like this one, where we can see that for a certain prediction, here 99.9% image sentence alignment, the modality contributions were 81% textual and just 19% visual. And we can also see a token level, what the contributions are for the image and text tokens. And we can look what happens with data from VALS if we have an error in the caption, and how the multimodal contributions change, and also how the token level contributions change. And this was at sample level, but at dataset level, our findings must challenge the belief that unimodal collapse, where a model predominantly relies on one modality, occurs uniformly in one direction, because we observe instead that some models are balanced, some use the image modality more and others the text. And especially VLM decoders use the text predominantly, which makes sense because they're initialized from language models with strong linguistic priors. And confirming our motivation that the multimodal score should not be based on accuracy, we also see throughout our experiments how accuracy and MMSHAP do not correlate. Now, having gained this insight after we interpreted the models, further we think that having a model self-explain its own predictions in words seems like an easier and less cumbersome way of studying a model's internal states compared to us interpreting the model. For example, we could just ask the model nicely to explain how and how much they used their modalities. And fortunately, LLMs and VLMs can produce explanations either in post-hoc after a prediction or in chain of thought before the final answer if we ask them nicely to. Only that this new generation of models has answers and explanations that can be unstable, contradictory, and utterly misleading, because research finds that model outputs and explanations can be either too sensitive to misleading inputs, or sometimes they're not sensitive enough to misleading inputs, and we never know in which regime we are. So we would like to have a faithful explanation that accurately reflects the true reasoning process of a model, such that for a certain answer and explanation, we can determine whether the explanation is faithful or unfaithful. And existing work on testing for this has several shortcomings. They're either meant for post-hoc or for chain of thought, and post-hoc tests did not test modern models. Also, some tests work only for specific data sets, and different papers do not use the same models and data to compare to each others. Some tests require semantic evaluation of the explanation, which is actually an unsolved problem. Tests only have binary verdicts, but do not deliver a continuous measure of faithfulness, accounting for the fact that half of the explanation might be faithful and the other half not. Also, their verdicts basically just rely on the effect of input editing on the model output, but some models just lack the capabilities to react to such input edits. And because they just compare outputs with input edits and without the edits, without inspecting the internals, these tests actually do not in fact judge a model's faithfulness, but their self-consistency. And we agree that it is really hard to actually get to this faithfulness, but at least for now we want a better self-consistency metric that doesn't have all these first 6 shortcomings. So for this, we devise a score for self-consistency called CC-SHAP to measure how much after SHAP interpretation input contributions for answer prediction and input contributions for explanation are alike. CC-SHAP is a continuous value between -1 for opposing contributions and 1 for perfect self-consistency. So unlike all previous tests, CC-SHAP is more than a test. It's a continuous measure of self-consistency. Also, it's interpretable because we get an indication of where answers and explanations use inputs differently, and it works to both post hoc and chain of thought, and it does not require semantic evaluation, nor annotated data, nor input edits, and it even works for weaker models like GPT-2 that do not react to input edits. So we can get sample level interpretations like this one for LLMs, where we can see how the input contributes for the model prediction, for the model explanation, and CC-SHAP tells us how much they're aligned. And the same for VLMs, where for prediction, for explanation, we see input contributions for the text, for the image, and CC-SHAP tells us how much they're aligned. But to evaluate the effectiveness of CC-SHAP, we need a comparative consistency bank, as there's no ground truth for explanation faithfulness, and all previous work does not compare their tests on the same models and data. So the idea is to compare to see whether existing self-consistency tests are consistent among themselves. Therefore, we evaluate tests from the literature and CC-SHAP on 11 LLMs on 5 tasks and see that existing tests show great divergences among each other, especially for GPT-2, where they disagree the most. We see that base LLMs are less self-consistent than chat models, and we do not see any trend between size and self-consistency, at least for the size range of the models we could test. Also, we do this for VLMs, where for the first time we apply self-consistency tests to the VLM setting on 3 decoder VLMs on 6 tasks, including tasks that require free-form generation from the models or multiple choice outputs, where we also include all 6 vals instruments. And we see that VLMs are less self-consistent than LLMs. And the reason is that the image contributes significantly more to the explanation generation than to the answer generation. And this difference is even larger in chain of thought compared to post hoc explanations. So this was it. We are at the end of all the contributions of the thesis that we have already published code and data for. And these contributions have already presented in papers, most of them already peer-reviewed. These papers were also accompanied by other papers during my PhD time. And I hope you found this talk at least a bit interesting. And now let's go on to the next chapter of this video. Now, let's talk about the challenges I encountered during my PhD. When I tell my story, it might sound like it was all smooth sailing, but trust me, it was sometimes really tough. One of the biggest challenges with intellectual work like this is procrastination. There's no one forcing you to work at any given moment, and deadlines often seem too far away to be actually intimidating. Despite this, I managed to stay focused most of the time because a huge help was my supervisor's weekly meetings. Even if I had no progress to show, we would just have relaxed discussions about the research topic, and these meetings kept me grounded and focused, especially in the early stages. Over time, I became more independent and I didn't need as much guidance. Instead, these sessions became more about getting a reality check, letting her review my thoughts and ideas, and getting valuable feedback. Oh, I just mentioned reviewing, because yes, during a PhD, you're expected to review papers. It's a skill you can pick up fairly quickly. But the real challenge for me was receiving reviews. It's heartbreaking when your well-crafted work gets superficial feedback or when reviewers don't even bother to understand the concepts. I even got a review once that was clearly written by ChatGPT. To handle this, I had to learn a few things about the review system and not take everything personally. Sure, my paper was a significant time investment and an investment of all my knowledge, but I am more than a paper. Sometimes a reviewer might reject your work for reasons as trivial as not agreeing with a widely accepted definition you used. And I also realized how random the review process can be in this rapidly growing field filled with more inexperienced researchers than actually seasoned experts. Review season is always an emotional roller coaster for me, but I've learned to manage it much better over time. Another challenge in the ever-exploding field of machine learning was the constant risk of getting scooped, someone else doing the same research and publishing it just a bit faster. This happened with my first paper. While I was wrapping up my project, I saw the exact same idea pop up on arXiv, but reading the paper and seeing that the thought process and the implementations were not as deep as mine, I was a bit disappointed. At the time, I didn't handle it well. I heavily compared my work to theirs, showing how I was approaching the problem with more depth, but the comparison led the reviewers to dismiss my paper as just an incremental improvement. And looking back, I realized the better approach would have been to acknowledge the simultaneous development and stand my ground, instead of framing my idea as an improvement over theirs, because we developed this independently with our own perspective. Then, of course, there was the COVID pandemic, which threw a wrench into everything. For 2 years, I was working entirely from home, juggling administrative duties and adapting my teaching methods. This sudden shift skyrocketed the time spent on side quests, making it hard to maintain a good work-life balance and get research done. However, once the initial chaos settled, I taught myself the necessary skills for the online world, including video lectures and live streams. And that, my friends, is what directly led me to start this YouTube channel. During the pandemic, teaching became a whole new ballgame. Reliable internet for live lectures, not exactly a given in Germany. So I had to pre-record my lectures and then hold interactive sessions afterwards. For the first time, I found myself standing in front of a microphone and a camera, and I was trying to act natural. It was tough, but over time I got better, though there's always room for improvement. Being forced to do it was a great way to overcome my shyness and try something I never thought I could do. And to my surprise, those videos weren't half that bad. It turned out it was not okay with everyone to put those lectures into the open internet, so I decided to do shorter form content explaining nuggets of insights about concepts and papers I've come across. And I was not brave enough to show my face back then, so I quickly drew Miss Coffee Bean here and voila! The first video was out, and growth was slow at first. YouTube's paradox is that you need viewers to get more viewers. But eventually my videos started gaining traction, and for this the first lesson was just to keep making videos. Even if the first videos were mostly watched by my friends and family, the more videos there were, the more other people stumbled upon them. The second lesson was to actively promote the videos on other social media platforms. As I was creating more videos about papers, I could mention the authors in my posts, and they would sometimes share the videos on their accounts. And that led to noticeable spikes in viewership, especially if they had already some followers. And as the numbers of videos on my channel grew, people started to stick around and subscribe. And I'm still extremely grateful for every single one of you. YouTube quickly became a wonderful source of moral support. Seeing all the time these positive reactions and comments, especially during the pandemic, was incredibly uplifting. And of course, this continues to this day. I read every single comment and it means the world to me. As the channel grew, it became my online business card, showcasing my expertise to a wider audience. And this visibility led to exciting job offers and collaboration opportunities. Sponsors started to reach out, and one of the toughest things I did during my PhD was not reviewing, not getting reviews, or not writing a paper. It was setting up a business in Germany to have the legal means to receive any money and haggle my first contract with a sponsor. I knew that I could never have done this part without my partner, to whom goes a big thank you. So what began as a necessity during the pandemic evolved into a powerful tool for personal and professional growth, opening doors I never anticipated. When it comes to advice for future PhD students, I could list the usual tips you'll find in any blog post or PhD journey story, but I want to share something unique from my experience: the value of having an online presence. In the past, business cards were exchanged to share contact details and profiles. Today, face-to-face meetings are less common, and I often find myself searching for a researcher's online presence. Too often I find nothing beyond their papers. Just a couple of blog posts, recorded talks, or videos can serve as an excellent online business card. Why? Because these snippets give a glimpse into who you are and what you do. It is like having already done an interview process with somebody, and then I know whether I find a person interesting to work with or not. I'm not saying everyone should become a YouTuber and churn out over 100 videos like I did. No, just a small online presence, a couple of blog posts or videos can make a significant difference. The leap from 0 to 2 is much more impactful than from 2 to 100. Or at least this is what helped me be more noticed, build my communication skills, apart from all other skills a PhD taught me, such as critical thinking, research methodologies, scientific writing, resilience, and so on. So, would I do a PhD again if I had a choice? Oh, absolutely. To conclude this video, my PhD journey was a challenging yet incredibly rewarding experience. It taught me more than I could have ever imagined and opened doors I never knew existed. If you're considering or currently pursuing a PhD, remember that it's a marathon, not a sprint. Embrace the challenges, cherish the learning, and don't be afraid to put yourself out there. Thank you very much for joining me on this Special AI coffee break. If you have any questions, comments, or want to share your own PhD experiences, drop them below. And don't forget to like and subscribe and hit the notification bell for more content.